Welcome to today's webinar. And first and foremost, I want to thank our speaker of the day, who is Rashmi Nagpal, for making the time and doing this for us and for the Agile TD community. So thank you, Rashmi, and welcome.
It's a pleasure to be here again. Thank you so much.
So before we actually go into the webinar, just a few announcements from our side. Very exciting, actually. The call for papers for the Open Air just started, for the Agile TD Open Air next year in Germany in June. So if you have any ideas, obviously for a 25-minute talk or 105-minute workshop, we would love to hear it. The call for papers is open until mid-September. So start early, do a little pairing session with someone, get a mentor, make sure that you get the best out of your idea and polish that abstract, send it to us. We can't wait to see all of your ideas. So just a nice little call out to do that for us and with us. If you want more information, just go on our website, openair.agiletestingdays.com, and see what exactly we're looking for, what the hot topics are, and how to submit. Second thing, as you know, we're going to have the 15th anniversary of the Agile Testing Days. And for that, we have a very special package, which is the virtual pass. So everybody who's not able to join us on site can join us online. And you'll get to see all the keynotes and talks live streamed onto your screen, and another huge package of online talks just present in that attendee hub. So if you want to find out more about that, just go to our usual website, agiletestingdays.com, and see if this is something for you. So thanks again for being here. And to go on, I would just quickly run through Crowdcast with you, so you know all the options you have. On the right-hand side, you already see the chat. Our moderator today is Julia, so she will share some information about the topic and also about our speaker today. And if you have anything to say, add it in there. If you have a question, however, please go to the question icon on the right-hand side below the chat symbol, post your question in there, or just upvote one that's already been posted. And after the 25-30 minutes, we'll go back in the Q&A tool and we'll just go through those questions. And below, and this is important for today, you'll find the poll feature, so the little bars. And Rashmi, in her slides, has two questions that are coming up during her presentation. And you can find those two questions already in the poll. And I would simply ask you to just jump into the polls whenever Rashmi is in the point of her presentation where that's becoming valid. So that's important for today. Other than that, nothing really to say, only that the replay is available in a matter of seconds. So if you want to rewatch the thing, if you want to share it with someone, you can do that. And also it will be uploaded on our YouTube channel. And now I would just actually say something to Rashmi. So Rashmi is a wonderful human being, and we are very happy that we met her. She has done her Agile Testing Day speaking debut this year in Chicago for the Agile Testing Days USA with the exact same talk. And it's been surprising and great to meet her, because on spot, she just won best rated session of the whole conference, which is a huge thing. And I think it's wonderful. And you will know in a minute why. Maybe that's just all I need to say. She's great. And we'll love to see her again soon in one of our conferences. Other than that, I hope you're having a great time, and I'll see you in about 25 to 30 minutes. Rashmi, I'll give it up to you and see you in a bit.
Thank you so much. Okay, can I share the screen now? Okay, I'm sharing my screen. And here we go. Okay, so again, welcome everyone to this amazing conference / the webinar. So I presented this topic during the Agile Testing Days US at Chicago this year, and I'm super excited to be sharing again my learnings with a larger audience this time. Okay, so a brief bio about me. I'm a software engineer by profession, but also a researcher by passion. And again, the topic of the talk or this webinar is going to be Unleash the Black Box, Testing Machine Learning Systems. So the agenda of the talk is, firstly, we'll understand what is machine learning and its related concepts. And then we'll understand, how black box problem, a black box could lead to some unfair and biased decisions. And further on, we'll explore what is machine learning test pyramid and how test-driven development ensures the faith. Faith implies that fairness, accountability, transparency, and ethics in machine learning systems. And towards the end of the talk, I'll briefly cover what are the technical debts which occur whenever we are developing machine learning systems and what are the strategies that we can use to mitigate them. And of course, I'll leave you with a bunch of resources for future reference. So without any further ado, let's begin. So let's understand the broader meaning of machine learning and its related domain. So, like AI in general, it's a very broad term, which implies that a program or a technique which mimics the human behavior. While machine learning, it's kind of a subset. It's basically, it focuses much more on the development of the algorithms, which learns from the data set and its corresponding features, and then it gives you an output. And the deep learning, it's a subset of machine learning, which extracts the patterns from the data set using the neural network as the core building blocks behind it. For example, handwriting recognition is an example of the deep learning, and spam email detection is an example of machine learning. All right. So now, since I have explained the very basics, let me test the waters. I want you to take a minute and think. There is a poll, the question 1 in the poll section states that, think which of these faces are real. Face A is a real one, whether face B is a real one, or a face C is a real one. I'll just wait for a couple of seconds so that the people can actually, reply on that poll. All right. Okay. Now I feel that, sometimes or the others, I would think so, that people must have felt like all these faces are real. Well, the news says none of these faces are real. At least these people do not exist on the planet Earth, to say the least. I'm not sure about the extraterrestrial planets. So this is an application of the deep generative modeling, in which the algorithms are not only learning the patterns from the data set, but they are going a step beyond in synthesizing the brand new data instances. But wait a minute, what's the building blocks behind all these deep generative networks? So that's where the neural network comes into the picture. So this is a basic structure of the neural network, in which you are given a data set as an input, and let's consider machine learning for the time being as a black box, which comprises of the weights, sum and bias, and activation function. And then it gives you an output. The output could be related to whichever use case that you're trying to make your modeling around. And let's understand this entire structure through an example. So this is my Fluffy, and this is an application of the image recognition. Given an image as a data set as an input, so this image will be bifurcated, or you can say that it will be processed in a form of zeros and ones, in a combination of zeros and ones, because the computer will understand only in the binary, like in the combination of zeros and ones. And then applying some image recognition algorithm, it gives you an accuracy / confidence that this is how the output looks like. Or with 92% accuracy or in confidence, this image belongs to the dog or animal, whichever category to it is. And with 8% confidence, it is a cat. Okay. So now we want to deploy this image recognition model into the real world scenario, in the system. So what will be the machine learning pipeline in that case look like? So this is a very high level infographic which shows the end-to-end machine learning pipeline or machine learning system holistically. It comprises of basically the 3 stages. The first is the build stage, the next is the deployment, and the last one is the monitor stage. So in the build stage, you are not just only ingesting the input data set, but also pre-processing and post-processing the data, also doing the model training and model testing, and further packaging and registering your model. But in the deployment stage, you are not just packaging and production release and testing it out, on the real-time data set. But in the monitor stage, what happens is you are not just monitoring, you are analyzing and governing over the period of time how the model is performing. And if needed, you'd circle back to the build stage. So this is a very high level of machine learning stages, and the pipeline looks like. But wait, what if something goes wrong? Especially in the build stage, or maybe you can say in the testing stage. So let's see how we can mitigate or look in for the methods where we can actually look in for the ways when there is some builds, when there is some configuration which is needed. Okay, so now let's understand the core problem of this entire talk through a couple of examples. So this is an example of the biased face recognition algorithm in which, unfortunately, the model was not able to recognize the face of an innocent child with a darker skin shade. Similarly, this is an example of the word embedding. It's a biased word embedding in which you can see in the Cartesian plane or in the vector space that the affinity of the homemaker is much more towards the women as compared to the man. So, you know what happens in the word embedding is, so you can consider the word embedding, it's kind of a vector representation of the words in a vector space. And the intuitive meaning behind the word embedding is that the words which are closer in the meaning, they are similar, the words which are similar in the meaning, they are closer in the space. So does that imply that homemaker and women, they are same? I mean, they sound similar. Well, the news is, unfortunately, that's true. Because the word-to-vec algorithm, whose representation is shown here, it's trained on a biased Google News data set. And we know that when the data set is itself biased, therefore the output is going to be biased, you know. And also for the future reading, you can refer to the book or a very known research paper, which is titled as "A Man is a Programmer and a Woman is a Homemaker," which highlights the bias which is ingrained in the machine learning systems or in the machine learning algorithms and what are the ways to mitigate that. Similarly, he is the doctor and she is a nurse, and that's how the word embedding representation shows that. Okay, so the next and the very shocking example that I can give is for the chat GPT. Here in the chat GPT, when I input the prompt, that is, the doctor yelled at the nurse because he was late, and the question which was followed up with that is, who was late? And the response given by the chat GPT is, in the sentence, the doctor yelled at the nurse because he was late. And the reference of the he, which is a pronoun, it backs to the doctor rather than the nurse. So logically, the nurse was the one who was late, right? And the nurse was a male, right? Not the doctor. But the input, or you can say the output being given by the chat GPT is the other way around. Similarly, the next input which I fed, or the prompt you can say it fed to the chat GPTs, the doctor apologized to the nurse for her late arrival to the emergency room and who was late previously. So again, here the circling back of the pronouns and just, affinity of the, again, he towards the doctor is more as compared to the she. And similarly, the affinity of the she towards the nurse is much, much higher as compared to the he. Similarly, there is one, again, a very, shocking example I can say is the nurse apologized to the doctor for his late arrival to the operation room and who was late. So the same prompt, again, there was this little bit tweak and the response given by the chat GPT is even more surprising. I mean, the statement given by the chat GPT is, the use of the pronouns in the sentence is unclear and therefore it assumed by itself and gave you the certain output. So the response, or I would say the caveat behind showing all these examples is to put a seed of curiosity within you all, is that we as users consuming all these technologies, are we aware about the inherent bias which is already present in such systems? Well, let's see. Okay, so after pondering over the couple of examples, and of course their biased, unfair outcomes, now it's time for us to introspect. How we get here. How can the models output such discriminatory decisions? Firstly, we understood what was the reason, what was the problem which was happening, and now let's understand the root of that problem. Okay, so these are a bunch of the reasons which I have laid down. First of all, again, when we have the biased training data set, as we see garbage in, garbage out, right? So if you have the biased data set, of course, your model or the algorithm will give you the biased output. And when the diversity within the data set is so sparse, or you can say there is a lack of diversity within the data set, for which the solution that you're trying to build upon, that also leads to biased results. For example, if you're building the face recognition algorithm for people from Indian geography, then generally in people from India geography, they have a lighter brown kind of a skin type, right? Like the skin color. So you should have the diversity within the data set. It should not be biased towards one kind of a skin color versus the other. And the next is the cognitive bias, evaluation metrics, and systemic bias. So for the cognitive bias, we are so much, I would say, so much engulfed in the inherent bias that we have, when the teams or the individuals are not themselves aware of their own bias whenever they are building, training, or maybe like at the deployment stage of the machine learning system. And the next is the evaluation metrics. So when the evaluation metrics are not in alignment with the objective that we're trying to achieve, So that also leads to the biased results. And systemic bias is it's a very known fact that when you say, for I can also give you an example for the systemic biases. It's well known fact that white collar jobs are just for the for the white people, or maybe like the design problems which exclude certain section of the users, especially those with the physical activities, when they have the physical disabilities, from interacting with the machine learning system. So systemic bias is so much baked into our lives that it shows up when we are training machine learning data, and also the design choices by default. Okay. So now it's time for us to explore the strategies, how to build fair and unbiased machine learning systems. First and foremost, the thumb rule is whenever we are training or building any machine learning model, it's important to have a diverse and representative data set. When you have the diversity within the data set, or it's well representative, it is going to serve huge number of population. And then it is also going to reduce the risk of the bias. And continuously monitoring for the bias, whenever you're building any kind of a model with appropriate metrics, helps to identify and correct any issues that could potentially arise. Next and third one is the pre-processing and the post-processing stage. So you can use techniques like the data augmentation, feature selection, reweighing mechanisms, just to balance out the data and kind of reduce the bias. I'll show through an example so that we can actually understand and comprehend this thoroughly. The next one is the algorithmic, fairness techniques that we can use. So using the algorithmic fairness techniques not just ensures that you are giving the output, or the model is giving the output which is fair enough across the multiple people from the different demography, and also it helps in understanding how the model is responding to various kind of inputs being given to it. And the next is explainability. So explainability is one of the very fascinating concept, which is, it helps to understand how the models are giving the output, who should be the responsible, and what are the output or the predictions given by models. Is it human comprehensible versus not? The next one and the last one is testing end-to-end machine learning pipeline, which is like the one of the very important factors. You need to test each and every component of machine learning pipeline. Okay, we'll discuss all these things in detail in the subsequent slides. Okay, so first of all, I want to give an example of the one of the strategies which I discussed in the previous slide, which is about the data augmentation, when especially during the pre-processing and the post-processing stage. So the application right now, which I'm trying to build, is a loan classification. For example, given a user, you need to identify, irrespective of the gender, age, ethnicity, whether that loan will be sanctioned to that person versus not. So so here I have used the UCI open source data set, which is the German credit data set, and these are the features which are present in that data set, that it's property, age, gender, and whatnot. And then again, because it's a textual data set, of course, you have to convert a textual data set into numeric format so that the computer or the model can ingest it. And then you use a strategy which is called as a SMART technique. So SMART, it's again a statistical technique. Why we are using SMART? The first and foremost rule is, whenever you are building any machine learning system, it's important to do EDA. EDA is explanatory data analysis, in which you understand what is the class representation, and is that the data imbalanced versus not. If it is imbalanced, then definitely looking for the strategies like the pre-processing stage and the post-processing stage, like the SMART techniques. So this is a data augmentation technique, which is a SMART, which is a synthetic minority oversampling technique, which I'm using on the data being given. And initially you can see that the representation of the 0th class was 569. And the number of instances for the first one class is 551. Similarly, after applying the SMART technique, now they are both equal. So it's a class balance which happened. So these kind of techniques, if you use, and whenever you're building any machine learning system, of course, the model is not going to be skewed towards one group over the another. So that's how you can use one of the strategies to reduce the bias. Okay, so now let's understand the ML test pyramid. How the machine learning testing pyramid is very much different from the traditional software, I would say, software development test system kind of things. So let's see various levels of testing which are required whenever we are building machine learning systems. So these are the bunch of strategies, or I would say the testing techniques that we used. Definitely unit testing is core and important part. You are not just testing the output that you get, but also at every stage. You can use the unit testing in the machine learning, which involves a machine learning system, which involves not just testing the data pre-processing stage, feature engineering stage, but also in the training algorithms and other essential components. And the integration testing is like verification of the interactions between the compatibility and the between the various components. It's generally used in the data pipeline, whether the data that you're getting from the various sources is well representative enough versus not. For the model testing, if you want to see how the model is performing actually, so in that case you can use accuracy, precision, recall. These are certain strategies that we can use whenever we are building any model testing kind of a test framework. Robustness, deployment, ethical and fairness testing again goes back to the line, what is the final outcome that we really want to see, whether it's well representative enough versus not, whether it's not biased towards one group over the another. So other techniques like the deployment testing that happens in the validation stage once you have thoroughly built a model. And also machine learning system, they can have like ethical implications such as the privacy concerns. There could be some algorithmic biases, there could be or maybe like some unintended consequences there could be. So you need to test for the ethical considerations. It's so much vital that you need to see how you should write the test and use the metrics which ensures that models are also fair and unbiased. So let's see the unit and the model testing in action. Okay, so here I am building a testing framework on the application, which is a sentiment analysis. So I'll explain what is a sentiment analysis first, and then we'll understand, and then we'll write some test cases for the sentiment analysis. Okay, so what happens in a sentiment analysis is, given a text, you need to identify whether it's a positive sentiment versus a negative sentiment. What I meant by the positive sentiment is, for example, I'm super grateful to the Agile testing, the organizing committee, and of course, for encouraging me to talk and share my learnings here with all of you. And also, I'm very much I would say I'm so blessed and grateful to so many mentors that I've met while I was present in person at when I presented in person in Chicago this year, especially Jenna and Elizabeth. Really, they are like so. So it's kind of a positive sentiment, right? I just can go on and go on. So you can see the positive sentiment which is coming out of me. Similarly, pink color. Again, it's a personal choice. So, or maybe like you can say, I don't like the pineapple on a pizza. So again, a personal choice. It's a negative, annotation which is associated with that particular sentence. So again, in the sentiment analysis, you are given a sentence. You need to identify whether it's a negative, whether it's a positive sentiment, right? So first of all, installing all the packages and libraries which are available. And then you build a sentiment classifier. So what happens in the sentiment classifier? It's an algorithm, right? Here you are putting all the data set that you have get, then wherever the data set that you want to extract, or maybe like just synthesize the data set. And then you convert that data set in the pre-processing stage into the tokenizer or vectorizer format. And then you build a pipeline in which the data set is being ingested and which classifier that you want to use. Already existing pre-trained classifiers are available, so you can use those classifiers. And then you call a train function which just fits on the text data set and of course the labels which are associated with it. And towards the end, you do the predict sentiment given on a text data set. So the data set could be like unseen data set on which the model has never been trained, or it could be some 80-20 ratio. For example, given a sample of 1,000 rows of the data set, you can put the 80% of that data set as the training and the 20% on the testing side of things. So we built the sentiment classifier, and now we want to test it out, how it is performing, whether it is giving good results, whether it is justifying to what we really want versus not. So here for testing, I have actually used some small sample of the data set, which is the sample of the data set is something like, so the text, which is list of strings, it's, I love the beaches, the movie is terrible. So every text is, it's mapped to a label. What I meant by the labels is, I love the beaches. So it's a one label which is associated with it. One is a positive, 0 is a negative. This movie is terrible, and therefore a 0 label which is mapped to it. And then I call my sentiment classifier, and then I train on this and then want to test it on. Once I have trained, now the model has learned. Now it's time for me to test the classifier on the new text data set, which is not seen by the model before. So here the text is so exciting to be presenting in the Agile Days conference in Chicago. So the response being given by the the sentiment the sentiment ones, because we are predicting on the text data set, which is again a testing, then it says it's 1. So 1 again is a positive. So it implies that, okay, our model is performing well. I mean, it's giving the justified result as to what we anticipated. Okay, but now I want to define the model testing. I want to do the model testing, which is again one of the stages for the ML test pyramid, right? So for the model testing, what I'm trying to do right now is I want to see the accuracy of my model, whether it's accurate enough, whether it's precise, its recall and F1 score. So these are again mathematical terms that you can use and just to calculate out how your model is performing really well or not. So here I see that the accuracy of my model is like 80%, which is fair enough, right? Because the data set is super small. So the model is, you can definitely use much more data set and you can increase the accuracy. Again, the accuracy is not correlated with the number of the number of rows of the data set that you have. But again, if you have the well representative and a diverse data set, so the accuracy should definitely go higher. So this is how the accuracy of the model looks like and the precision and recall. So this is example of the model testing. Now I want to do some unit testing. Okay, for the unit testing, there's already existing frameworks available in the Python, which is a PyTest. Here, again, I'm calling the sentiment classifier and also mentioning, okay, this is the training data, this is the test data, and I want to test it on certain aspect of the data set. Here I'm just marking, okay, test sentiment classifier, which is a function, and then you put in the sentiment classifier, training and the test data, and what is the expected sentiment of that particular the text which is being given. So here we can see, okay, all the 3 test cases have run through. So it implies that, okay, our model is performing like really well. So that's how you can see for the unit testing, whenever you're testing your system or machine learning algorithm, okay, whether it's performing as to what is the expected sentiment for that versus not. Okay, so this is an example of the unit testing. Now it's time for us to understand the test-driven development, how it plays so much critical role in addressing the issues like fairness, bias, accountability, and explainability in ML systems or ML models. So let's see. But before that, have you understood what is fairness in machine learning models? Let's see. So, the fairness in machine learning models takes 2 main categories or brackets, you can say. First is with respect to the protected attributes. What happens, so what I mean by the protective attributes, it could be a sensitive attributes like, age, gender, ethnicity, demography. These are all protective or sensitive attributes corresponding to a user. So what happens whenever we are building any fairness in machine learning models, with regards to the protective attributes, we want to check whether the lending authorities are free to have their own protocol or eliminating or not sanctioning the loan to the people, but just eliminating them on the basis of the gender. That's not a correct lens to look at the things. Therefore, we want to do the fairness with regards to the machine learning models. And with regards to the outcome is, when the model does not harm or benefit any one particular group over another, or maybe like one individual over the another. And I can give one very famous example, which is well renowned as well, is the Amazon hiring algorithm, which was released like a couple of years ago, though it has scraped up at the moment. But the Amazon's hiring algorithm, it was discarding the women applicants, those who had the same caliber, or I would say the same level of experience and the skills as their male counterparts. Though it was scraped off, but the underlying fact or the learning is that the model should not disadvantage one group over the another on the basis of, especially on the basis of their protected attributes or the sensitive features, right? Okay. So let's see the next question which pops in my head. Okay, now we have understood fairness. How can we actually inculcate fairness while we are building the test cases? Let's see that. So there are a bunch of techniques that we can use. Definitely the highly, I would say, the well-renowned ones are the demographic parity, statistical, and equal opportunity. So what happens in the demographic parities, you want to ensure that the model's predictions are similar across all demographic groups. For example, if the loan prediction is trained on an unequal distribution of the different ethnic groups, then demographic parity will ensure that your model provides similar loan rates across all the ethnic groups. Similarly, for the statistical parity, it calculates the difference between the probability of the positive outcomes between the privileged and the unprivileged group. I'll explain this in detail and also give you a demo so that we can understand it thoroughly. And the last is equal opportunity difference. So what happens in equal opportunity, it basically gives a difference in the true positive rate between the privileged and the unprivileged group. And on the basis of our own hypothesis, we can define what would be the privileged group, what would be the unprivileged group, and also on the basis of the EDF. Okay, so here, given again the same, so I'm referring back to the same loan classification problem which we saw before. Here I've defined the privileged group is all the male beyond the age of 18, and unprivileged group is all female beyond the age of 18, right? And here I'm trying to use how the model, once it has been trained, whether it is giving equal opportunity or like fewer enough results versus not. Here we can see after calculating equal opportunity difference. Firstly, we need to provide the Y true, Y predict, unsensitive features, privileged and unprivileged group. And then we do some calculations around it. And then we see, okay, now equal opportunity difference on the basis of the labels / the data that we have put in on, what's the result which is coming up. So the equal opportunity difference is coming 0. So what does that imply? So basically it indicates that the model is providing a fair treatment, in terms of the positive predictions across various groups. The model's performance is not at all changing, or I would say it's not creating any kind of a bias or just favoring one group over the another, but actually its performance in identifying the positive instances, it's consistent for both the groups, for privileged as well as unprivileged group, without favoring one over the another. Okay. So now there is a question in the poll, which is, who should be responsible for any kind of a biased, or I would say unfair decisions given by the machine learning model. I'll actually give you a couple of seconds again, because I really want people to answer to that question in the poll section, which must be available and visible to all of you. And then I'll start. Okay. So you know what? So people are, so this entire machine learning system, when it is developed, or I would say it's brought in the market, it's not the one person who is working behind it. It's the data scientists, developers, business leaders, visionaries, regulatory bodies and organization, and of course, we as consumers. But since all these multiple stakeholders, they are involved in this entire stage from development to the building to the deployment stage of the machine learning system, so definitely we can't pinpoint, someone one in particular. Oh, you are the one who was solely responsible for creating an unbiased results. You were the one, you should be responsible or taking more responsibility over the another. No. So all of them, all these stakeholders, they need to work, I would say, in collaboration, so that it's important that they take in their responsibility with definite plan and action, so that we definitely get a fair and unbiased result and an outcome. Now, the next question is, or I would say, what's the transparency in machine learning models? So this is my all-time favorite topic. Okay, now we have built the models, we have trained and tested. Are the machine learning models really transparent? Are they human comprehensible versus not? So transparency, it's directly, I would say, it's correlated with the trustworthiness of the models. So let's see how first we build trustworthy or the transparent models. But do you really think that the trust is critical when we are adopting or we are building, machine learning systems? Well, the answer is definitely yes. Okay, let's understand through an example. So here the users, they need to trust the machine learning system so much so, because not only machine learning system is providing them the accurate, reliable and unbiased results, but the user's trust lies within the core of it. This means if the users will not trust the system, then they're less likely to adopt it, which will lead to the poor outcomes, or I would say the poor decision making and missed opportunities between the users and the organizations those who are developing such systems, right? For example, in the medical diagnosis, be it in healthcare or be in the autonomous driving, so there are a bunch of applications where the stakes are super high. So the machine, the decisions made by such machine learning models, it play a significant role or impact on the people's life. So it's very, very vital, or I would say critical for the users, that they should build the trust within the machine learning system, that it will provide accurate and reliable recommendations. But however, for building the trust, we know that machine learning system needs to provide the transparent and explainable results, right? Because users need to understand, how the system is working and why it is making certain decisions. And they also need to know who should be responsible for the system and how they can themselves be held responsible for its actions. Okay. So next strategy, or I would say the next question, which is, can we really build some strategies to have the trustworthy systems or trustworthy models? Well, definitely. So these are some bunch of strategies. Again, not a exhaustive list, but definitely gives like the bird's view of the holistic strategies that we can build. First is collecting and utilizing high quality of the data set on which you want to build your model, or you can say, your working towards kind of a population. So the data which is used to train the models, they need to be again comprehensive, representative, because it helps in preventing bias and it will also ensure the fairness. And then plugging in the explainable and interpretable models not just helps in building the transparent and interpretable systems, but it also will help the users so that they can increase the trust in the model, and also they can reduce the risk of the black box problem that we see, right? And the next one is again the regulatory monitoring. So you need to evaluate your models and regularly monitor it so that you can understand why the model is giving some haywire results. For example, you have trained the model on a data set which was trained in 2019. Now you're still using that same model, which is in 2023. Is the model performing the really best? Is that the model in a scheduler mode / auto tuning by itself? So you really need to think through that it should not be trained. It could be trained on the stale data set for sure, but it should not give the results which are corresponding to the stale data set, versus it's not getting improvised by itself on the real time or the new data set. Right. The next one is, you need to involve a lot of stakeholders. Again, you can't work in the silos, especially when you're developing such systems, because because the stakeholders, or whenever you involve the stakeholders, it will not just ensure that the system meets expectations, but of course the needs of all the users or the end users / the consumers, and therefore it will help in building the trust. The last one is regularly updating and improvising your model. So when you regularly update and improvise your model, it will ensure that your system is definitely current, it's reliable, it's accurate, and will prevent the system from becoming outdated or biased over the period of time. Okay, so these are the bunch of strategies which you can definitely follow to build, the trustworthy, or I can say the transparent models. Now, let's understand what is explainability in machine learning models. So, explainability explainability is in a sense to understand whether the output given by the model is comprehensible versus not. And there are so many approaches that we can definitely use to understand this black box. So, again, I would say explainability refers back to the ability to understand and interpret how machine learning model arrives at its particular predictions. Why it is giving a decision, we really need to know. And therefore, an explainable model, it helps in providing the insights into the underlying factors which helps which influences its kind of a predictions or decisions, thus making it comprehensible for humans. So why explainability is important? Because when we are dealing with the sensitive applications in the healthcare, be it in the finance or in the criminal justice, you definitely don't want an innocent person to get, to be behind the bars, right? So you definitely need more accountability, your transparency in the models. Therefore, it is so much vital. Okay, let's understand that explainability aspect of this talk through a demo. So here I'm giving you an example which is reference to the sentiment classification, which I explained in a couple of slides before. So once we have built the sentiment classifier, now it's time for us to understand, okay, now you have given me, okay, it's a positive sentiment, but why it is so? What are the reasons? What are the words which contributing and telling the model, it should be a positive sentiment? So here, the text which I want the model to explain to me is so exciting to be presented at the Agile Testing Days conference in Chicago. We know that it's a positive sentiment, right? But we want to see which words are contributing towards it. So here, using the Lime explainer, again, it's a package inbuilt in the Python, so we can definitely use the Lime. Using that package, we understood, okay, so exciting at, these are the words which are contributing, and also what is the level and how, with what strength, I would say. So we can see, these words are the ones which are contributing why it is a positive sentiment, and at what strength is something like this. That's how we can see the visualize it. This is so much comprehensible now. With 68%, I would say, okay, that's a positive sentiment. With 0.32, that's a probability. No, it might not be. So it's a fair enough, right? So it's very much comprehensible again. Okay, now there is a very hot topic, and that's the very last leg of my talk, which is, what are the technical debts which occur whenever we are building machine learning systems? But first, let's understand what are the technical debts in machine learning systems. So there are a bunch of debts which could possibly occur, not just in the data, that's the pre-processing or the post-processing stage, even before than that, which is the data. Whenever we feed in the data, then only we will do the pre-processing and post-processing, right? And there could be an architecture debt as well. For example, if we have built a very overly complex kind of machine learning architecture, and it has become disorganized over a period of time, and also it is poorly documented, then of course it's a bigger bottleneck, right? In algorithmic depth, in a sense that, okay, if you're using your model on some outdated or suboptimal approaches and techniques, when it is making so much assumptions, so that will lead to some biases, right? It could be a selective bias or any other cognitive bias, or maybe like some other stream of bias it could be. Therefore, it's very vital, whenever the new methods emerge, the system should get updated by itself. Or maybe like we need to have a particular pipeline when it gets updated, and then also retraining. It should happen, the retraining, so that it can handle the new approaches. This process, though, could be difficult if the architecture is so much, disorganized. But definitely with certain techniques like the data pipeline and streamlining the process, if they are designed, then it's very much easier to accommodate those changes. And next one is lack of monitoring. So machine learning systems, if they're not properly monitored, especially when the data distribution is ever changing, or the performance degradation is happening, then definitely there will be so much issues or bottlenecks which could possibly arise. And it will also become like risky to maintain over a period of time. So having a technical debt in the form of inadequate monitoring and alerts will also, it will, your efforts will also like compound over the period of time. So definitely you need to have, might have to discard the system and altogether. So these are the various ways, various debts which could possibly rise. And documentation debt, if you're not have a well-written documentation, again, the new onboarding, new joinee or someone else who wants to refer back, it will be like a huge bottleneck, I would say, again, in that case. Maybe they don't, or maybe like if there is a significant person within the organization or within the team who leaves, then a lot of time will be wasted in understanding or just rediscovering how the system actually functions. And lack of the test, of course, it's very much, I would say, again, a huge part of the puzzle in which you can say a technical debt which happened. So having a very small tests which are not robust enough could also could also lead to the biased systems. Okay. So what are the ways or the strategies that we can use to address such technical debts in machine learning systems? There are a bunch of approaches definitely we can use. The first is review your machine learning pipeline. You need to go through the entire machine learning pipeline, which could involve the data pre-processing, post-processing, collection, even the data collection stage, in fact, to the model and the deployment stage, and kind of review in a sense, because it helps in identifying any kind of a potential technical debt which could possibly arise, and therefore you can address by maybe like automating them or just streamlining the entire pipeline. The next one is the data quality issues. You need to check. So as I said before, garbage in, garbage out, right? If you have a biased data set / if you have the input data set which is of a poor quality, so it's going to leave it's going to affect other aspects of your machine learning system. So definitely look for any missing values, or if there could be some bias or some label errors, and understand what is the feature distribution within your data, and try to address them by improving the data collection measures. The third one is you need to examine your model's performance. If your model's accuracy or other metrics, if they have degraded over the period of time. For example, you train a model back in 2020, but in 2023 your model is performing not really well and it's giving like lesser accuracy than what was anticipated, then definitely you need to understand maybe the data could be an issue, maybe the model performance is not upgraded with the new data which has been put in the new pipeline. So you need to evaluate it, also just examine it. The next and the fourth one is evaluate the model, model's explainability. So we do definitely say that the models which are opaque or the black box, they are not easy to be diagnosed or updated, but you need to see if your models can be made much more transparent. As I gave an example of using a line, you can use some other, there is a SHAP. All these kind of frameworks all are available and open source. So definitely using these tools helps in understanding and identifying or making just much more comprehensible why the model is giving certain kind of a decision. The fifth one is adopting the automated testing practices. So investing, a lot of time, first of all, in setting up the comprehensive automated testing really gives you the fruits later on in the stage when you have already deployed your ML system. Starting from the unit, integration, model, end-to-end testing, not just it helps in ensuring that your entire system is very much stable, or your code base or your model or entire inference pipeline, training pipeline is stable, but it also helps in catching the regression or just helps in facilitating if there are some future changes which might be needed. And the last and most important is performing the regular code refactoring. So code reviews are definitely one of the best ways to identify if there are any technical debt early on in your earlier in your stage of the machine learning pipeline. So definitely refactor any kind of repetitive code which could possibly be there. Okay, so now let's head to the conclusion. So the main and the key important takeaways from my talk are, you need to have a definite and a comprehensive testing, because it not helps in unlocking any kind of potential bottlenecks which could possibly arise when you have deployed your machine learning system, but also it helps in ensuring that you build fair, reliable, and unbiased machine learning systems. And the ML test pyramid, as I shown in one of the slides before, it provides a comprehensive framework for right from the very first stage to the last stage. And also it helps in thorough coverage of your machine learning system. And lastly, TDD definitely promotes fairness, accountability, transparency, and builds the explainable ML system, which is definitely important to incorporate TDD practices while we are building such systems. And these are a bunch of resources which I would definitely, I would recommend that one should look in for. And the third one is a course which is by MIT, and it's an open source course, Introduction to the Deep Learning, and really one of my favorite courses, I would say. So please check it out, and a bunch of again book and blogs and articles. These are also like a couple of resources for the future reading. So that's all I have for you today. Thank you so much for listening and being a warm and lovely audience in here.
Hello. Hi, Rashmi. Thank you so much. As before, I can only say I'm amazed by the depth of your knowledge and all the tips and advice you give. This is amazing. And I'm sure you should, I know you will and should do a workshop about this. I think that would be awesome, so that we have all the chance to kind of look into it and do a hands-on work on examples that you just did. So thank you. Thank you. Really nice presentation. And I think it was very valuable to me. It was, and I think to the audience as well. So I think I do have one question here for you. I would just post this. Can you say something again? I think I can't hear you.
You can hear me, right?
Sorry, yes. I can. Sorry, my mistake. So you're audible. It's all good. So I'm just going to quickly move to the Q&A here. So Karen, hi Karen again. Hi. Karen has joined us today, and she has asked a question. When you find issues with fairness and biases, how do you approach your team and begin the conversation of change?
I think that's a very vital and important question that Karen has asked. Someone has to start from somewhere. It might be, the data quality is not that great, or the model is giving the biased results. So, firstly, understanding and approaching the problem, especially for the developers, those who are working on this. Whenever they are doing the EDA process, EDA is explanatory data analysis. Then they will definitely understand, oh, there is some ingrained bias in the data set. It could be the data distribution, frequency, what class labels, so whatnot. So for having the developer understanding, from the developer point of view, and then reaching out to the manager, or maybe just discussing within the team in itself, and trying to comprehensively find a solution towards it. It could be, so there are some chances, like sometimes I face a situation when the delivery is like, okay, I have to deliver the product, or I have to deliver this feature like in 2 weeks, and now I found a bottleneck in my code, or maybe like it's giving biased results towards what particular section. Then definitely reaching out to the higher authorities and conveying that, okay, this is how the model is performing right now. Having that kind of a hard conversation is one of the best, and I would say thumb rule for every developer who has to who's ever is working on this, and trying to find a middle ground, how we can actually inculcate various practices, and will not release out that model unless and until it's fixed. So that's also one such way in which I think, as a developer by myself, I can say reaching out and highlighting the fact to my manager, or the senior authorities. It's important. And also for the visionaries, sometimes, oh, we need to deliver this product, or this feature by a certain deadline, but what if there is a bottleneck? So having this kind of a conversation is really, really important. Yeah, being open and vulnerable at the same time is important.
Thank you. I think we have another question. I'm going to go back in and reload. Let's see. No, those were all. Those were all. So we're good here. Obviously very comprehensive. So if anyone has questions, again, that might come to mind, or when you need some help with the resources we just saw, just ask us in the Slack channel. I think Rashmi will be happy to guide you through any of the resources she just shared, or examples she did. And yeah, Rashmi, again, I'm thanking you very much for taking the time to do this. I'm really looking forward to see you soon at any other of our conferences, maybe doing a workshop next time. And for everybody who has watched, thanks for attending. And make sure to join our next webinar, which will be on October 4th with Mazi and Inat, also on test automation and how to maintain test automation models so that they're testable. So he's also a great speaker, has been to the Open Air conference. So check it out and sign up to it. And also, if you want to watch the replay here, it will be available as long as you have a Crowdcast account. So you can go back anytime and see it. And yeah, Rashmi, thanks again.
Thank you so much.
Everybody else. I hope again, sorry.
Thank you so much for giving me this opportunity. And I think I would just want to say one liner to the Agile Testing Days, entire people, like everyone within this conference was so much humble and lovely, and I could easily feel so much connected. Thank you so much for giving me this opportunity again.
Oh, you made my day. It's raining cats and dogs in Germany, so thank you for that. That makes a bit of a sun come out to me, to all of us. So thanks also for those nice words, Rashmi. Appreciate this. And for everybody else, have a lovely day. Have a great rest of the week, and we'll see you October 4th. Goodbye, goodbye.